Hey everybody, this is Alex Merced, and again, if you've been enjoying this Intro to SQL series, make sure to like and subscribe and leave a comment with your thoughts, and also to make sure to follow me on Twitter and on LinkedIn. But with no further ado, let's get more into SQL. So in this video, we're going to be getting into SQL joins. So using multiple tables and being able to kind of create a data set based from multiple tables. Now, in this case, the code for this one will be inside this joins.sql file. So basically, if you take a look at the link in the video description for this particular REPL, you'll find that. You can find the code in the joins.sql. I have it loaded up into my main.sql. Because again, the way REPL is going to work is that whenever I hit run, it's going to run the main.sql. So first, let's talk about the setup. Okay, so we're going to create two tables, employees and departments. So you can see here, we have an employee ID, so the ID for each employee, and each employee is going to have a name, and each employee works for a department. But notice we don't write the name of the department. We provide the ID of the department, and this is generally how we relate data in relational databases. Okay, and again, I will do a separate video specifically on data modeling to kind of help make this more clear. Okay, so keep an eye out for that video coming up once we're done with the SQL bit. So probably after we cover window functions. But what's going to happen here is, gathering my thoughts, is that we're going to join that with the data in the departments table. So here we'll list each individual department, okay, and basically each department will have an ID. So basically we can figure out which department they work for by finding that ID in this table. The benefit of this is if you have multiple employees working for the same department, if the department changes its name, I don't have to update multiple records because we reference basically the information. They're all referring to the same record in another table. This is also referred to as sort of a normalized data set, where basically you take chunks of information, put them in their own separate tables. And actually, you know what? I'll save that for the modeling video. We'll get more into that. But the whole normalization, denormalization, and foreign key relationships and all that fun stuff. So in the sense that we have a primary key, which is the key, in the employee table, the primary key is the ID of the employee. A foreign key, which is what the department ID field is a key referring to another table, in this case referring to the departments table. Okay, but basically we create these two tables. So we have these two tables. We're going to put data in these two tables. So here we're inserting into the employees table, and here we're inserting into the departments table. And then from there, we'll begin doing our joins, which actually, let me comment out these queries one by one. So that way we can do them one by one. Okay. Good. Okay, so let's take a look at the first query. So what we're going to do is we're going to do what's called an inner join. Okay. So how does that work? So imagine this. Basically, what we're going to do is select all the employees. We only want their name, and we only want the department's name. So notice how we specify, we don't say employee name this time. We say employees.employee name. Because once you have multiple tables in the mix, you might have multiple tables that have fields with the same name. So in that case, when you're doing joins, you want to put the fully qualified name of the field, which means the name of the table dot the field in that table. Okay, so those are the two fields that I want. Okay, I'm starting with the employees table, which is going to be the table that is on the left. So when you think about it like a Venn diagram, so for example, if I were to build two circles, okay, this one will be yellow. Okay, this one is going to be with the employees table. And this one will be the departments table. Okay. Now what we want to do is we have these two separate tables, and I'd like to look at their data in a unified way. So when we join them, essentially what we're doing is we're taking one table and then kind of connecting them. Okay. Now how am I connecting them? Well, we're going to say, hey, anywhere where the employees dot department ID equals the department's dot, what do they call it? What do we name it in this? Department ID. Okay, anywhere those two things match, okay, that belongs in this middle area. That's the stuff that kind of overlaps. That's referred to as an inner join. So basically, the only records we want to see is where there is a match on both sides. So if the employee has a matching department and the department has a matching employee, we want to show up there. I don't want to see any departments that don't have an employee in them, and I don't want to see any employees that don't have a department in them. I just want to see the overlap. Okay, that's called an inner join. So as we'll see here, that's exactly what we're doing. We're taking the employees table and we're inner joining it. So we only want to see that inner overlap with departments. And the way we determine when there's a match is the on keyword. So we're saying, hey, anywhere where the department's ID of the employee matches the department ID of the department. Okay, and on that, that's all we want to see. So if I hit run, okay, we see this data. So let's take a look. Let's kind of match it up. So let's see here. We have John Doe, who works for Department 1, which is Human Resources. So that matches up. Then we have Jane Smith, who works for 2, which is Marketing. That makes sense. Then we have Jane Smith. Oh, no, we did that. Alice Johnson, who works for 3, Finance. We see that. And then we have Eva Brown, who also works for Marketing. And we see that. Now, I don't see IT because there are no employees that work in IT. I don't see Bob Williams because they don't work for a department. So in that case, you're only seeing where there's a match. That's an inner join. Okay, so we're only seeing the match. Next, we're going to do is a left join, I think. Let's see here. The next one, next example is... Okay. As we see here, yep, is a left join. So left join, what we're doing is we're looking at anything that is in the employees column and anything in the employees table and anything there's a match. So the only departments we'll see are ones that match. So we won't see IT, but we will see Bob. Okay, because Bob, it doesn't matter if they, in this case, we are including the not matches in the employees column. Okay, so you can see there, again, we specify left join instead of inner join. And again, we say on, and then you say, hey, what's the matching criteria here? Okay, so now if I run that query, as you see here, now we see everybody. We even see Bob Williams, even though Bob Williams doesn't have a department. So that is a left join. Okay. Then let's do 3. Now, the thing about a right join is that a right join is not supported by SQLite. So we cannot do that for this particular database, but it would essentially be what you'd think it would be. It's anything inside, any matches, and any departments that don't have a match. So we would see IT, but we wouldn't see Bob. Okay, and we'd see the other employees because they all match. So that would be a right join, not supported by SQLite 3, but is supported by other databases and other data SQL platforms. Okay, and then a full outer join, also not supported in SQLite 3. Now what this would do is that it would just grab everything. So you would see Bob, you would see the IT department, you're just basically combining everything. Okay, and then there's also a cross join. Now a cross join is kind of weird because what it does, it kind of gives you all possibilities. So it's best to see it so you can see what it's doing. So it's not really so much a match. So notice there's no match logic, no like cross join on, because you're not asking it to match them. You're just trying to see what is every potential match possibility. So if I run this, see, I get John Doe with every possible department, Jane Smith with every possible department. You're just trying to see what every possible match would look like. In case you want to sort of see, hey, how many possibilities of mixing these things together is there? Okay. So that's essentially what that does. Okay. Cross join. Okay, and the last one is a self join. Okay, this is when something sort of joins itself. So it means, let's go an example here. Okay, so we're gonna say, hey, A employee 1 and employee 2. So basically we're gonna have 2 employees from employees A and employees B. So notice we have employees twice. So we basically have the employees table twice. Okay, we're not using the join keyword because we're not joining them as separate tables. It's a self join. And here I'm just saying, hey, anywhere where where the first employee's department ID equals the second employee's department ID. Okay, and basically where they don't, where their ID as an employee doesn't match. Okay, so if we run this, okay, and I don't think that's really going to find anything. Okay, yeah, I didn't find anything because none of these employees have IDs. But let's give these employees IDs. Okay, so if I were to go here and say 1, 2, 3, 4, 5, and then make sure that we include the employee ID here as the fields we're providing. Employee ID. Okay, and now if you run that last query should yield us some results. So if I hit stop, run. Okay, see, we see that these employees work in the same department. So Jane Smith and Eva Brown both work. And if I go back up here, we can probably see that. So we can see that Eva Brown works in marketing and Jane Smith works in marketing, which is exactly what this reflects. So self-join would be if you wanted to kind of see, hey, I want to get all employees or see employees that work in the same department. And as we saw here. And notice I'm not using a join keyword because there's not necessarily a foreign ID. There's no employee ID field to join with. You're not joining on a foreign key. You are using sort of other characteristics that might connect other records in the same table and using the where clause to kind of express them. So again, I'm basically selecting from two tables, which is the same table twice. I give them each a distinct name because when you have the name of a table, or really anything, you can hit space and then give it like a nickname. Okay, it's almost the same as using the as keyword. Okay, and basically I can then reference them as two separate tables, even though it's the same exact table, to express the logic of saying, hey, I want to see employees that have the same ID and ID number. Okay, this is fine if you're looking for pairs. Chances are I probably would have used like a group by statement if I wanted to look for basically people who work, everybody who works in the same department. Or actually, you don't even need to do that. You could just do a normal filter. So where, department equals marketing per se. But again, it's something you can do when it is relevant. Okay, so for example, you might be looking in a table of people looking for like a person's spouse. Okay, so basically you want to look for, hey, where the person's name matches this other person's spouse name. Okay, so in that case, it'll check to see, hey, is this person actually that person's spouse? And then you can see the matches in there, even though they're all people in, let's say, a people table. Okay, so those are just some examples of joins, but joins allow you to either join the same table, join multiple tables. You can join as many tables as you'd like, so you can do really large, complex joins, but that's the purpose of a join. Bigger the data set, the more intense joins can be. So this is where you start getting into the conversation between having like normalized data sets where everything's kind of separated out and then you join, versus denormalized data sets where kind of everything's in one big giant table. That's a debate depending on your use case. And again, we'll talk more about that and when we talk about data modeling and more data optimization type considerations in future videos. Right now, we're just kind of exploring, how do I write SQL? Okay, so I am going to comment that out and I'll see you all in the next video.